It is another day. It says that we have an 8-hour session on Twitch. That's not correct. There we go. Today is the second day, despite what you may believe, in the Advent calendar. Let us get on with it. So I guess I'm seeing the pattern now. Is we have this input, and then we have to do some weird calculation on the input, and then be finished. So let's see. Yeah, we U-mount. We switch to Serenum. So the task is, let's see here. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. And then you sum these up. Red, 13 green, 14 blue was the sum of the IDs of those games. So let's look at the file here at the end of the file. So it ends with a clean new line. That's good. So I'm thinking, because we don't care about what it actually says, because the games go in linear order, we ignore the number, and then we skip to the comma, past the comma, and then go through. They're not in the same order, which is annoying. But I guess that's fine. Yeah, so we pass a number, then check what the number was. In fact, we could simplify this down. We only care about the failure condition. And so, and the failure condition is based on, in this case, can the is the number of supposed colored cubes, say red, does the number of red cubes in one occurrence go above the amount? So we can in fact just scan the line and go through and say pass a number, then which color was that? Check that against the thing. And then if we get to the end of the line without failing, then we can mark it as good. Now I wonder, there's no character here on the end, no. So we can chop we can go up to here and then one extra, and then that's a symmetrical case. Pass the number, check if it's blue, red, whatever, and then you advance and you get here, and then you say, is this a new line? If it's not, you advance 2 characters and then you're back at the same state, because these are the same here. Instead of importing these, I'm just going to write a string compare here. And we'll just assume that they're the same size. Oh, no, we don't have to do that. We can include this. So we get the input, and then we want to have the current line. And I think we want a cursor as well. And then I guess this loop is in here. We say while cursor is less than or yeah. So we moved up until the colon, and then we want to advance 2 more steps. And then we enter a loop over the colors. So we say while the next character is not a new line. So sort of similar as at the top. I don't think we ever get a three character number. So I think we'll just pass the number manually and say so if the next character is not equal to space, because we know it's very controlled input here, so we can be sloppy. Oh, not equal to space, sorry. Then the first arg here we'll say num plus equals input C minus what U0 times 10. Yeah, so we take the character and we subtract 0, because then we get the character as a number. You don't have to do that with clear text, by the way, which is cool, but minor. And then we advance by 1. And then here we get to the normal case where we do the singles. Oh, and I guess we want to advance 2 spaces to include that, or 2 slots to get the space as well. Now we have to pass the color or something to that effect, where we say if string equal red with yeah, so say we had red, and then red is obviously 3 characters, so it'd be input C dot dot 3. Then we do the stuff here for red. Yeah, which here we'd have some variable where we say failed. Yeah, failed. So if we have red, then I'm worrying about possibility where we might crash, but we'll solve that if it comes up. So we have we can actually solve this now. So what we do is we say sub equal, and B, we only fail if B dot M is less than that. So basically if the substring matches. No, sorry, yeah, that's the case. Then we return 0, otherwise we do the check with A's length. And now we just have sub equal. Just go to the end. So what was the requirement from the challenge? It was there are only 12 red cubes. So we'd say failed or equals none more than 12. And then we'd advance C by 3. And now we just do the other cases. Green, how many green were there? There were 13 green cubes. There are 5 letters in the word green. And then for the remainder case, we don't expect, so we'll just abort here. See, this is just like exclude, or what's it called? The match in Rust, where they want you to be handle all the cases. You just put, if it's none of the above cases, fault. Now what do? We say well, I'm interested. No, I'm not really. So we'll have out here the game sum, or the sum failed to 0. Alright, so now we've gotten to the... Or we've passed the color, and now we have to advance 2 more steps. Exactly. Yeah, that works in all cases. Great. And then coming out of this, well, actually we should move this to the top. So we should remove that. Yeah. Because the final game has a new line straight away. And we want to check for that. So we hit the new line, and here is where we increment a line. And then at the end we say we'll see if I get it first try this time. Run me dot noob dot see. Start asm -u. Sum is 38,38357. Do we think this is the correct result? 38,357. That is not the right answer. It is too high. Okay, let's set up the example input instead. We have the example here. if I the sum is 80 apparently. Which is not correct at all. Because there are 5 games. Curious that. Oh, I see. I think I know what the error is. This is not where to add the thing. Right, failed. This should be done outside the loop. Silly me. Now we get 8, okay, which matches the example description. So if we now run this on the full input, we get 2,632. 2,632. That is the right answer. Very good. Part 2. We're doing a lot better on time this day. Okay. Stop producing snow because they aren't getting any water. What is the fewest number of cubes each color that could of each? Wait. As you continue, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? In game 1, 4 red, 2 green, 6 blue. Yeah. Game 2 could have been played with a minimum of 1 red, 3 green, and 4 blue. The power of a set of cubes is equal to the number of red, green, and blue cubes multiplied together. The power of the minimum set of cubes in game 1 is 48. For each game, find the minimum set of cubes that must have been present. What is the sum of the power of these sets? This should be pretty easy, if I'm going to be honest. Because we just go in and grab the minimum. So instead of failed, we'll have red or RC, GC, and BC. And so in here we just say if num is more than RC, set RC to this number. And then for each game, yeah, so there's no, so this is RC times BC times GC. Is this the same example text? Yes, it is. T 286, that indeed matches. Then we run this on the input. Get 69629, which we will input here. 69629. It is indeed the correct answer, and with that we finish the stream.